The lack of lossless zoom in smartphones prevents you from taking truly incredible photos. With the explosion of image sharing platforms and new tech like AR, smartphone companies became obsessive over having the best cameras, and especially over having the highest quality zoom. Samsung acquired Core Photonics for $155 million in 2018, with other smartphone companies spending similar amounts on other camera startups. Last year, Apple devoted 20% of its press conference to talking exclusively about the iPhone 11's cameras. And Phil Schiller, Apple's top marketing executive, called out the camera as his favorite part of the new iPhone. Suffice to say, they all care very deeply about keeping their photographic capabilities competitive. The most notable of their recent camera improvements have been dual apertures, which take two photos at two fixed zooms to help guess what desired photos should look like. But the trends towards triple, quadruple, and even quintuple apertures show these solutions aren't sustainable, don't solve the underlying optics problems, and have actually degraded other smartphone aspects. They reduce battery size, use exponentially higher processing power, look aesthetically unappealing, cost significantly more to manufacture, and hold back focusing-based technologies like augmented reality. Other attempted solutions like periscope lenses, clip-on lenses, or mechanically bending lenses all come with laundry lists of drawbacks, failing to solve the problem. A great solution needs to be cheap, thin, and aesthetically pleasing, but it can't rely purely on software to follow modern smartphone restrictions. Current solutions aren't meeting those requirements, and smartphone lenses, a $16.7 billion market, still desperately need to be redesigned. We're Scope, and we're creating lossless zoom using liquid crystal lenses. Liquid crystals are like grains of rice suspended in a gel, except when we put an electric field through them, the crystals reorient. Their orientation affects how light bends passing through, so with just an applied voltage, we can make light dynamically converge or diverge. One lens can change its focus, three stacked together lets us achieve lossless zoom, with a system we estimate is 50% smaller and 15% cheaper than any market alternatives. That saves $5 billion a year across leading smartphone models, on top of taking higher quality photos. Most importantly, liquid crystals are the only tech we found capable of such a comprehensive improvement. Since liquid crystals can also be found in display and solar panel technologies, smartphone lens manufacturers will be able to tap these existing processes to prevent any significant supply chain overhauls. We've also ensured all of our prototyping methods have remained consistent with industry capabilities. Smartphones are an ambitious market, but they're not the only product suffering from poor quality zoom. We'll be licensing our IP directly to lens manufacturers who, in addition to designing smartphone cameras, supply other billion-dollar markets with less strict technical restrictions. These will be our first targets. Through them, we can refine our tech and accumulate capital while staying committed to our long-term smartphone goals. We validated these market opportunities through meetings with over 90 professional camera engineers, lens manufacturers, and display technologists, and are in the process of formalizing our first letters of intent. In fact, just the other week, we secured our first LOI. Behind this vision is an amazing team of nanoengineering students with a decade of combined experience in optics, liquid crystals, fabrication, and simulation. We have incredible advisors, such as the world leader in optics, Dr. Van Gu, and the prolific liquid crystal researcher and Dean of Science, Dr. Bob Lemieux. Our progress has been extremely exciting. We custom built our own multi-physics module from scratch to simulate our lenses, since nothing off the shelf could meet our needs. Using this, we prototyped over a dozen tunable lenses, achieved industry-level liquid crystal alignments, and built a working proof of concept lens, shown here focusing and defocusing one of our lasers. We also designed and ordered custom lens masks for much higher precision prototyping. While working from home, we're designing and validating a full zooming system that we plan to prototype when labs reopen, hopefully in the next few months, all in parallel with extensive patent reviews to ensure all our designs remain novel and patentable. We're also planning on filing our first provisional patent at this time. The novel IP we're developing is multifaceted and includes the lens structure, optical formula, and the software powering it. At Scope, we're creating a lossless zooming system that'll save $5 billion a year across leading smartphone models after we already bring our tech to other lucrative lens markets. We've built proof of concept lenses and custom optical simulations validating our designs. We're currently developing a high quality and patentable full zooming system, along with securing, successfully, our first letters of intent. Our expert team is focusing on what's important, fixing smartphone lenses to let you take great photos. Thank you.